Welcome to another session of Ebenezer GATE coaching classes. This is a problem that appeared in GATE 2014. Is a multiple choice question for 1 mark. Consider the feedback system shown in the figure. The Nyquist plot of G of S is also shown. Which one of the following conclusions is correct? G of S is an all-pass filter. G of S is a strictly proper transfer function. G of S is a stable and minimum phase transfer function. The closed-loop system is unstable for sufficiently large and positive k. Now, here, if G of S is an all-pass filter, that means for all frequencies, the gain should be the same, or gain should be 1. So that means magnitude of G of j omega should be 1. So what is magnitude of G? That means it's a circle with unity radius. So it should be a circle with unity radius. So this is 1. So this should have been the Nyquist plot. But here we see that it is not in this at 0. So the actually the magnitude keeps changing for different values of omega. So it is not an all pass filter. Number one, strictly proper transformation. What is a strictly proper transformation? Where if g of s is numerator function by denominator function, numerator degree should be less than. Suppose numerator degree is s cube plus 4s squared plus 3s plus 1. Denominator should be 1 degree more. That is s power 4 plus 5s cubed plus 3s squared plus 2s plus 4. 5. So when that means as s tends to this is g of s. This is g of s. So if s tends to z infinity, g of s limit s tends to infinity or omega tends to infinity, this should go to 1 by s power 4 is almost equal to 0. That means this Nyquist plot should pass through 0 for some frequency. But here we find that at no frequency it is passing through 0. This point, this point is 0, and this Nyquist plot is around that but not passing through 0. So it is not a strictly proper transfer function. So this is not a strictly proper transfer function. Is stable and minimum phase transfer function. What is this? This is encircling the origin. G of S is encircling the origin in the clockwise direction. That means what is n for an open loop transfer function is p minus z, where p is the pole and z is the 0. So p, the number of encirclements of the origin is in the clockwise direction. That means it is minus 1. Minus 1 is p minus z. Suppose we assume that there is no pole on the right of this plane, that is 0. 0 minus z. So z is actually 1. That means there is 1 0 on the right half of the S plane. 1 0 on the right half. That means for a minimum phase system, all zeros and all poles should be on the right half of the left half of the S plane. Here 1 0 is in the right half of the S plane. So it is not a minimum transfer function. Next, the closed loop system is unstable for large value of k. When the value of k, if you multiply it by k, and for the large value of k, it's just, it will then encircle minus 1. So it will become like this. That means there's an encirclement of minus 1 in the clockwise direction. So minus 1 equal to p minus z, where p is the open loop poles, which we have assumed is 0, and z is the number of closed loop poles. So here z equal to minus 1. So that means z equal to 1. So z equal to 1 means there is one pole of the closure transfer function which is in the right of the spring. So that means It is unstable for large value of k. So the option is T. Thank you. God bless you.